moving on. The next one, I see that I have a 1/5 in the denominator, so I'm going to pull that through just to get that out of the way. I'll write this as 1/5, and then the integral 0 to pi over 2, and the sine of x dx. Okay, so that 1/5 is just going to kind of hang out front for a bit. The integral of sine of x is the opposite of cosine. So let's pull the negative through as well, and we'll just write the cosine of x, and we'll evaluate that from 0 to pi over 2. Okay, so we can maybe even do that. So you can see that this is only applying to that cosine of x. Keep this guy out here. Okay, the cosine of pi over 2 minus the cosine of 0. And now we're going to have to figure out what's the cosine of pi over 2. So pi over 2 is right here. And we're going to need 0, so I'll do that now too. Okay, so we have negative 1/5 times the cosine of pi over 2 would be 0, minus the cosine of 0, which would be 1. And so in the end, I'll be multiplying negative 1/5 times negative 1, and I will get positive 1/5. Okay, next. Alright, nothing needs to be rewritten here, so the integral of secant squared is tangent. So the tangent of x from 0 to pi over 3. Okay, so the tangent of pi over 3 minus the tangent of 0. Okay, so just again, people who are good at trig, this is no problem. People who are shaky, you'll just have to, you know, I don't even know what I'm trying to say. Try to get yourself back in the game here with this trig stuff. The tangent of pi over 3 is a 60-degree angle. So let's draw a reference triangle, 30, 60, 90. Okay, so the tangent is opposite over adjacent. So the tangent of 60 would be root 3 over 2. Nope, root 3 over 1, so root 3. I'm losing it. You can tell I haven't been here in a while. Okay, the tangent of 0, now that's a quadrantal. So if you look at where 0 is, we have the ordered pair 1, 0. Okay, tangent is sine over cosine. So I'm getting 0 here, getting me my answer of the square root of 3. Okay, so we had some trig review there. Now let's go through and have some logarithm review. Might as well erase those two. Okay, so again, if you want, you can pull that 5 through. You don't have to. Like the time I did that with the fraction, you don't have to do that. But if you think of it, you can. So I am going to do that. I'll pull the 5 through. Okay, that allows me to focus on the integral of e to the x. So the integral of e to the x is e to the x. So I'll put my 5 here. I'll put my e to the x. And I'll be evaluating that from 0 to the natural log of 3. Okay, so 5 again hangs out. I need e to the natural log of 3 minus e to the 0. Okay? So e to the natural log of 3, this is a property of logarithms from pre-calculus. I guess to help you maybe recognize it, right? Natural log is log base e. So e log base e of 3 is what we're really looking at here. And the property was when these are the same, see how e and e are the same and the bases are the same, the answer is just the power. So the answer is 3. It's not a power, actually, though. Okay, so we'll put 3 here, and e to the 0 power is 1. So in the end, 3 minus 1 is 2, and 5 times 2 is 10. So I'm getting 10 for that answer. Okay, over here, integrating 1 over x. Now this is one from your neon sheet, so hopefully you remember this. The integral of 1 over x is the natural log of the absolute value of x, And again, that has to be evaluated. What's that number there? Is that a negative? Oh, it's a negative, or the opposite of e. It's a negative 1. Okay, so let's sub that in. So we have the natural log of the absolute value of negative 1 minus the natural log of the absolute value of the opposite of e. So this becomes the natural log of 1 and the natural log of e. So the natural log of 1, again, this is, review for the whole logarithmic lesson in pre-calc. Let me write here, I'm just going to come right here to do this. Natural log is, again, log base e. So log base e of 1 is equal to what? That's your question mark. If you do the pattern, e to what power is equal to 1? And that answer should be 0. So the natural log of 1 is 0. Okay? This guy over here, if I rewrite that one, wouldn't it be log base e of e? And does everyone remember that that's 1? Again, if you're not sure, make it a question mark. Apply the pattern. E to the question mark equals e. So, of course, the answer would be 1. It has to be a first power. So I'm going to subtract 1, and my answer is negative 1. Okay? So again, those of you who are rusty with the logarithms and natural logs, you're going to have to brush yourself up on those skills. That's what I was looking for earlier. Brush yourself up on the trig and the natural log stuff. I'm not good with words. I'm a math girl. Okay. All right, last one on this page. So before we start it, take a look at it. What's weird about this? Hopefully you see that the bounds are the same. And we actually had this defined previously in our notes, so you may just immediately know the answer, but let's say you don't remember. You would just go through, integrate x to the third over 3, say I'm going from 1 to 1, and what happens when you sub in a 1 is you get 1/3. And then when you subtract, subbing in a 1, you get 1/3. So the answer is 0. So again, this is actually like a property. Anytime the bounds are the same, the answer is going to be 0, and that just makes sense looking at our work here. Okay? All right, almost finished. I think we're on our last page already. Okay, number 6. Notice, please, that the bounds from 4 to 0. Do you see that the lower bound is higher than the upper bound? If you notice that, you can switch them and just take the opposite of your answer. If not, if you just work through it, you'll get the answer anyway. So let's go through and integrate. So we're going to get x squared over 2, and we're going to go from 4 to 0. See how that's like a backwards look there? Okay, if we sub in our 0, we will get 0. And if we sub in 4, 4 squared is 16, and 16 divided by 2 is 8. So my answer is negative 8. Okay, so you can just go straight forward, and you'll get your answer that way. What I was saying with this is if you notice that this is backwards, you could rewrite your integral from 0 to 4 so that the lower bound truly is smaller than the upper bound, but stick a negative out here. You have to take the opposite since you're switching that order, and then you would just go through and do the same thing. So I'm just going to rewrite my integral and show you that I get negative 8. So again, x squared over 2, and I have to evaluate that from 0 to 4. I'm going to put that in brackets and stick this negative out front. When I take my 4 and sub it in, again, I'm going to get 8. When I take my 0 and sub it in, I'm going to get 0, creating this look, and in the end, you see I'm still getting negative 8. Okay? So honestly, I would just go straight forward and do it this way, but it's kind of cool to show you how that works. Okay? Next, number 7. We have a piecewise function. So they want us to evaluate this function from 0 to 6, but if you look, I need to use this function if I'm less than 2, and I need to use a different function if I'm 2 or larger. So I'm going to have to split up my integral here. Let me give myself some space to do this. Okay, so again, we have to look at where our piecewise function has been broken up. Okay, so clearly that's 2. So I am going to start with the lowest bound I have, which is 0. And I'm going to go from 0 to 2. Okay? Then I know that I'm going to have to continue, so I'll need to add an integral starting at 2 and going as high as 6. Okay, does everybody see where I get those numbers from? You want to look to see where these are being broken up, and you want to look at the actual evaluate problem to see, am I evaluating, the whole piece. So, if I am 0 to 2, so I'm less than 2, I need to use x squared dx. If I am 2 and larger, I need to use 3x minus 2 dx. So hopefully that makes sense in how I went through and I separated that. And now we just go through and we integrate each piece individually. So I have x to the third over 3, and that's going to be from 0 to 2. And I have 3x squared over 2 minus 2x. Put that in brackets and evaluate that from 2 to 6. Okay, and then, these start to get a little bit longer because you're subbing in so many values, but just be careful. Take your time, it's not too bad. Take the 2, sub it in. I'm going to get 8/3 minus 0. Okay, so that's the first piece. Over here, I have to sub the 6 in. Okay, let me put a bracket here, and we're going to focus on the 6. So 6 squared is 36. Times 3 divided by 2, I'm going to cheat real quick. I get 54. Okay, and I also have to subtract that 12, subbing 6 in here. Okay, minus, sub the 2 in. 2 squared is 4. 4 times 3 is 12. 12 divided by 2 is 6. Minus 4. Okay. So you can see in the second piece, my second integral, I had to sub in 6 to the whole problem, and I had to subtract that by subbing 2 into the whole problem. So in the end over here, we're getting what? 8/3 plus 54 minus 12 is going to get me 42 minus 2. So I'm getting 40. So 8/3 plus 40 is going to get me 128 over 3. And you probably will need to pause the video for a second to see the math between 8/3 plus 40. I just have to quick find a common denominator, which is 3. So take a second, pause it, and make sure that that makes sense to you, and see if you get that 128 over 3. Okay? And in the end, not such a bad problem. Just go through and make sure you split that up because of the piecewise. Okay. Okay, so this diagram is actually not on your notes, but it's a nice thing to see with what we're about to read. Okay, it says because the integral calculates the net signed area. So again, it's taking the positive and the negative and putting it all together. It says if we want the total area, we're going to need to take the absolute value of the function. So basically, if I ask you what is the integral of this picture, it's going to take the positive regions and it's going to subtract the negative and give you a final answer. But if I want the total area, then they don't want this subtracted, they want this added. And that's why they're asking you, or showing you, that we need to do the absolute value. And if you look at this picture, it demonstrates the total area. Okay? See how that's been flipped up, and they're showing the absolute value. So the total area and the net area are different things. The net area, you're allowed to keep that negative in there. The total area, you take the absolute value. And that does get more important as the lessons continue. All right, so the last example for us, okay, just trying to line this up. It says find the total area between the curve 1 minus x squared and the x-axis over the interval 0 to 2. Draw a graph to visualize. Okay, so again, we have an upside down parabola that's been translated up 1 unit. For those of you that like to make a little table, go ahead and do that. Okay. They only want me to go from 0 to 2, so we could do like a 0, 1, 2 in our chart. Sub in 0, get 1. Sub in 1, get 0. Sub in 2, 1 minus 4 is negative 3. So I come over here, and I draw my quick picture. Again, it's a parabola opening downward that shifted up 1, so that makes sense. Something like that. Okay, and it says the total area. Okay, and so if we look at this, that's our bound right there. We have some positive area, and we have some negative area. Okay, and that's why they're saying, we're going to go through and find the total area. We'll be allowed to take our positive area, but we'll have to take the absolute value of this piece and then add it to the positive. Does that make sense? Okay, so this actually is going to end up being a piecewise function because you can see I have to split this up into two integrals. This piece needs an absolute value, whereas this piece does not. So what I'm going to do is I'm going to go through and I'm going to start at 0 and I'm going to go up to 1. Why did I pick 1? Because 1 is my x-intercept. So this begs the question, I got that from my picture. What if I don't have a picture, or what if it's too complicated? How do you find an x-intercept? The answer to that question is algebraically, you set the y equal to 0. So if I set y equal to 0 right here, okay, if I go through, I'll do it this way. I'll add x squared, and then I'll take the square root, so plus or minus 1. That tells me that the curve crosses the x-axis only at 1 and negative 1. Negative 1 does not fall in my interval, so I don't need to worry about that, but positive 1 does. And as you can see, that's where this is coming from. So if you can't draw a picture, you should certainly be able to do the algebraic approach by finding the x-intercept, putting, your 0 here, your x-intercept here, and your upper bound here. Okay, so there's your lower and upper bound. And then just taking numbers and subbing that in. So something from 0 to 1. In my picture, you can see above, I should be getting a positive. If I take like a half, and I go through 1 minus a half squared would be 1 minus a fourth. That is positive. From 1 to 2, you can see in my picture, I end up becoming negative. Without a picture, let's see what we would get. Let's sub in 3 over 2, right? That's 1 1/2. So 1 minus 3 over 2 squared would be 1 minus 9/4, which in the end, that's a negative answer. So you can see that you don't really need a picture to figure this out. You can do everything algebraically using things that you've learned in the past, okay? You're starting to get an amazing bag of tricks at this point in your math career, so you just have to be able to think through it and think, hey, if I don't know this, can I bail myself out using a different method? That's how you can tell who's a really good math student. Okay, so going from 0 to 1, again, from 2 reasons here. I am going to not need an absolute value because we can see that I'm positive in both circumstances. So I have 1 minus x squared dx. Now, the next piece, this is where I'm negative. So instead of using absolute value notation, isn't it true that if you have a negative, if you take the opposite of a negative, it becomes positive? So I'm going to, instead of adding these together, can I put a negative here so that this negative and that negative turn to be a positive? Okay, that's how I would like you to handle this. So I'm going to put this here to turn the negative positive. And my lower bound to upper bound would just be 1 to 2, and then I put my function. Okay, so basically, when they ask for the total area, you need to find out if you're dealing with any negative region. If you are, you need to turn that positive and then add it all up. Okay? And to turn it positive, you can simply use the opposite symbol. Okay, so let's just do this problem then. I have to integrate, so I'm going to get x minus x to the third over 3. And that's got to be integrated from 0 to 1. Over here, we have x minus x to the third over 3. And that one's going to be integrated from 1 to 2. Okay, here we go again. Just be careful. Sub in our 1, and we're going to get 1 minus 1/3. Sub in our 0, and we'll get 0. Okay, over here. Sub in our 2, and we will get 2 minus 8/3. Sub in our 1, and we will get 1 minus 1/3. Okay, and so in here, 1 minus 1/3 is 2/3. Okay, and here let's take our time. So if I'm going to make this a common denominator, let's see, 3, so 6, that's going to be negative 2/3 minus 2/3. So that's a negative 4/3, which becomes a positive, so plus 4/3. And that adds up to 6/3, which gets me the answer of 2 in the end. It all works out nicely in the end. Okay, so total area, again, we have to turn the negative region positive. Okay, so that's it. That's the definite integral. Hopefully you won't find that too bad. Common mistakes to look out for. Last year, remember, some kids started subbing in the values wrong. Remember, you always sub in the upper bound before you sub in the lower bound. And also, some students started to mess up when the function got a little more complicated. They would sub the 1 in here and the 0 in here, versus subbing the 1 in to the whole problem and then the 0 in to the whole problem. So those are the two most common mistakes that I saw last year. So just watch for them and be careful. I hope everything's going well. I miss you guys. Today is actually April 8th, and I'll be back in about a month. I hope you guys are working hard. So I'll see you later. Bye.